Hello and welcome. Today we're going to be discussing the steps to solve a system of linear equations by substitution. This method of substitution is the idea of replacing one variable with another variable in order to be able to solve an equation. In our first step, we are going to solve one of the equations for one of the variables. All this means is to isolate either x or y, one of the two variables that you're working with. Step 2. We're going to substitute the expression from step 1 into the other equation and solve for the other variable. So that means we're going to now replace in our other equation one of the variables with what we've just solved for. And once we've done that, we can then proceed to solve for that second variable. Step 3, we're going to substitute the value from step 1 into one of the equations and solve. So all that means is once you've found one variable, you go back and you find the other. Now in example 1, we'll go through these 3 steps. Solve one of the equations for one of the variables. So looking here, all that means is that I need to make sure I have one of my variables isolated or by itself. And in one of my equations, I do. I see that that y is isolated, that y is by itself. So step 1 is done. Now step 2, we need to substitute the expression from step 1. So this expression here that we just found, we need to substitute that into the other equation. So we know y equals 2x. Y and 2x are the same thing, so they're interchangeable. Anywhere I see a y, I can go ahead and put 2x, and I haven't changed the equation or the expression. So down in this second equation, we'll call this equation number 2, I'm going to take that value of y, that 2x, and simply replace it everywhere I see a y. In doing so, this second equation now becomes 7x minus y, but we're going to go ahead and input something for y equals 5. So I'm going to now input or substitute that value of y with the 2x that we know it equals up from above. So 7x minus 2x is equal to 5. And now from here, this is an equation that we can solve. Since we have only one variable, I can now simplify 7x minus 2x to get 5x. That equals 5. And dividing both sides by 5, we find that x is going to equal 1. So this is the x value where our graphs intersect. So for example, what we've just found, if I were to draw my coordinate plane and graph these two lines, you might have two graphs that look something like this. Here's the first, and maybe here's our second. Now these might not be the exact graphs, but that's okay. All we are looking for is the point where the two graphs intersect. What we have just found here with this x equals 1 is that the two graphs intersect at an x value of 1. So now all we need to do is go back and plug that x value into either equation, it doesn't matter which one we use, and figure out where is the y value that these graphs are intersecting at. So right now our goal is to figure out this y value. So we can choose either equation. Whichever equation you find more simple is the one you can use. I think this y equals 2x is pretty simple. Since I know x, it's very straightforward to go ahead and solve for y. So in doing so, I'm going to say, okay, well I know that y equals 2 times x, but I also know the value for x is 1. So instead of 2 times x, I'll write 2 times 1, and solving, I find y is equal to 2. Therefore, the point where these two graphs cross is the coordinate 1, 2. Go ahead and take a moment to pause the video and go ahead and try just number 1 on your own. In doing number 1, our first step is to make sure that one of the variables is isolated in at least one of the equations. So in this case, we actually have the variable isolated in 2 equations. So here I have y by itself, but also in equation 2, I have y by itself. So I get to pick. I'm going to go ahead and say y equals 5x. So what I want to do now is say, well, I know y equals 5x, so I'm going to take this value of 5x and replace it where I see a y in the other equation. So I'm just going to take this 5x and put it in for y above. So now I have 5x is equal to 2x plus 3. And this is something that we can solve. Now that we only have one variable in our equation, we can solve for that variable. First thing I need to do is combine my x's by subtracting 2x from both sides. Now that I've done that, I have 3x is equal to 3. And dividing both sides by 3, I find out, just like in the last question, that x is going to equal 1. So again, on the graph, this is the x value where the graphs meet. So I just need to go back and find the y value. We know this x value is true for both equations, so it doesn't matter which one you pick. Just pick the one that you feel is easiest. I think that this equation 2, this second one, is a little bit easier, a little bit more straightforward. So I'm going to go ahead and use that equation to find the y value. So y is equal to 5 times x, but we know our x value is 1, so I'm going to go ahead and multiply 5 by 1. And when I do that, I find that y is equal to 5. So therefore, my solution, or the point where these two graphs cross, is the coordinate 1, 5. Now in question 2 and 3, these are the same idea, just a little bit more complicated because we do have some longer expressions. I'll go ahead and do number 2, and then I'll ask you to do number 3 on your own. So in number 2, our first step is to make sure that we have a variable isolated. In this first equation, x is not by itself, it's not isolated on one side, and neither is y. However, in the second equation, we do see that y is by itself, or isolated on the left. So I'm going to say, okay, well I know y is equal to 1/2 x minus 5. It's the same idea as before, the only difference now is that that right-hand side is a little bit more complicated than it was in the last examples. But we do the same thing. I'm going to go ahead and in the equation above, replace every y I see with the 1/2 x minus 5. So from that first equation, I now have 4x plus 2 times y, and I'm going to go ahead and use parentheses to make sure that I'm including every component of my y. But I know that y is 1/2 times x minus 5. Now the reason these parentheses are so important is because I want this 2 to be multiplied by all of my y. In our first equation above, it says 2 times y. Not 2 times part of y, 2 times all of y. So I need to make sure that I put my y in parentheses so that I multiply that 2 by all of it. Meaning, I need to go ahead and distribute my 2. So when I get to this distribution, I'm going to go 2 times 1/2 and 2 times negative 5. Below, I'll have 4x plus, now 2 times 1/2 is just 1x, minus 2 times 5 is 10, is going to equal 0. Now I simplify, I add and get 5x minus 10 is equal to 0. Add 10 to both sides, so 5x equals 10. And divide by 5 to find that x is equal to 2. So now that we know x equals 2, we're on to step 3 of our 3-step process. I need to go back and determine what my y value is. So we can plug this value into either of the two equations that were given. Whichever is easiest for you is the one you can pick. I think since y is already alone in the second equation, that I'm going to go ahead and use that equation to find y. So y is equal to 1/2 times x, and always use parentheses when you're plugging in a variable, minus 5. Now x is 2, so I'm going to replace x with 2. 1/2 times 2 is 1, minus 5, and I find that y is equal to negative 4. So what I have found here is that these two graphs intersect at the coordinate where x is positive 2 and y is negative 4. Now go ahead and take a moment to pause the video and try question 3 on your own. Since x is already isolated in this first equation, I just took the 5y plus 3, I know that's what x equals, and I plugged that in for x. I then had to distribute my 2 to the 5y and the 3. And combining like terms and solving for y, I found that y is equal to negative 1/2. Now from here, I need to take that negative 1/2 and plug it back in to find x, and I thought that this first equation would be a little bit easier, but if you don't prefer that, you may use either of the two equations. Plugging it into that first equation, I ended up with an x value of 1/2, leaving me with the coordinate where the two graphs meet being x is positive 1/2 and y is negative 1/2. Lastly, we're going to take a moment to just set up example 2. I'll let you guys solve this one on your own, but I do want to walk through the process of setting this up. You buy a total of 50 turkey burgers and veggie burgers for $90. You pay $2 per turkey burger and $1.50 per veggie burger. Write and solve a system of linear equations to find the number x of turkey burgers and the number y of veggie burgers you buy. So we're trying to identify two things. We're trying to find both x and y. Since we have two things that we want to know, that tells us that we're going to need two variables. First thing I know is I bought 50 total burgers. So if I just take the number of veggie burgers and I add on the number of turkey burgers, I'm going to get a total of 50 burgers. So this just represents the total burgers I buy. Now my second relationship is the price of everything. I know that it's $2 for a turkey burger, so if I take 2 and multiply it by the number of turkey burgers, this is the total cost that I spend just on turkey burgers. So for example, if I buy 3 turkey burgers, I have spent $6 on turkey burgers. But I also need to add on the number of veggie burgers that we're buying, multiplied by their cost. So I need to add on how much I'm spending on veggie burgers. So the amount I spend on turkey burgers plus $1.50 times my veggie burgers, that's going to give me the total that I've spent all together. And this is going to equal $90. Now that I have two equations, I can go ahead and solve for both of the variables. The only problem here is that it's not so direct to use substitution since one of the variables is not already isolated. But that's okay. All I need to do is a little bit of work to isolate one of the two. And you get to pick whether or not you want x or y, whichever seems easiest to you. So I can choose to get this first x by itself. I can choose to isolate this first y. Or I could say, hey, this second x looks pretty easy, or maybe you want to get the second y by itself. It does not matter which one you pick. I'm going to go ahead and choose to isolate this first x. I want that x to be by itself on the left-hand side. So all I'm going to do is subtract the y from both sides of my equation. In doing so, I now have x is equal to 50 minus y. And now I can go ahead and take this x value, take that 50 minus y, and replace it for x in my second equation. I'll let you guys go ahead and take a minute to pause the video and try doing this on your own. When you are done, you will find, if you've done it correctly, that we purchased 30 turkey burgers and 20 veggie burgers. In doing so, we bought 50 total burgers and spent a total of $90. Thanks so much for watching part 1 of Solving Systems of Equations by Substitution. Have a great day.